Okay, so I hope everyone is looking at this white screen board. So we looked at the what? Okay, great. So we looked at deriving the half angle formula for sine. So we are going to do it for cos now. So remember, when we are doing this half angle formula, what we are going to do is we use the what? We use the power reducing formula, okay? Like we did for sine. Okay, then over 2, right? So then what do we do now? Of course, what we are going to do at this point is then to we're then going to say introduce square root to get rid of that square. Then we're going to have cos x. Then remember, when you got a square root, it can either be plus or minus. But the main reason why we actually have this plus or minus, it's because of the quadrants, right? And you see when we start looking at our examples, that when you are solving these questions, you want to be mindful about the quadrant in which your answer is in. Okay, so that's why that plus or minus is there. Okay, so that when you answer, okay, anyway, but I'm sure you may remember this. All students take coffee, isn't it? All students take coffee. Okay. Anyway, we'll talk about that later on. Okay. So what we're going to have is, so then what we do is we make this one half, right? So if we make this one half, this means plus or minus. So remember, that's 2 where there is x, we put that. So you see that it's just going to remain x, right? So it's going to be cos x plus 1 over 2. Okay, so that's the half angle formula for what? For cos. So remember, the beauty about deriving these things is that first of all, it reduces the workload of memorizing. But again, the more you practice these things, the easier it gets with remembering them. So let's take note of that. Then now, let's now derive the one for tan. How can we derive the half angle formula for tan? So you may want to, so what I would do is I want you to see something. So I'm going to write it first, and then we are going to derive it. The reason being, I want you to see uh, a certain pattern. So we know that tan is what? Tan is is sine over cos, isn't it? So meaning that if you want, you can get the half angle. If you get the half angle formula for what? For this. And then, so that's for cos. Then you get the one for sine as well. Okay. Then after that, okay, so I hope everyone is following. So then after that, you're going to have over that. So when again, you know that when you are multiplying these things, you are anyway. So since you are dealing with square root, you could say, okay, let's get rid of the square roots because they both have square roots, right? So you have, or some people may say you just square everything, okay? But again, all the same, it's going to give us this over. Okay, so remember this is the dividing line, huh? So we know that when we're dividing, it's the same as what? It's the same as, anyway, we can, since they both have square roots, you can actually just combine the square roots, right? So rather than canceling, you can just say, okay, since they both have square roots, then I'm just embracing the square roots for both things, okay? I think that's a better approach. So they both have square roots, so you're just embracing both square roots. So, and then just make it one, right? Because it's the same thing, okay? Because how you can picture this is this. Remember, from your sides, this is the same as that, right? So that's the principle that we are using there. So now, here, there, and then with that, so we have, so multiply. So you know the two will go there, then this one comes down. So this is going to give us plus or minus. So that's going to give us, let's write it here properly. So this is going to give us plus or minus. So those two cancel, and then you're going to have great. So that's about it. So you see, you're just getting sine and putting in and over cos, right? So that's something that I wanted us to know. Then also there are the other forms of this equation. There are also other forms. Yeah, but yeah, you could use these, but the one that we've derived is the most commonly used. But also these ones, depending on the situation, you may want to use them. So you may want to use them. That then there is also this. Okay, so there are also these forms for the half angle of the tan. Okay, so again, yeah, so there are a number of things that you can look at. So having done that, then I think now it's about time that we looked at an example. So what we are going to do is we are going to look at uh, quite a number of examples, which I feel they are going to bring out quite important concepts. So what we are going to do is, uh, okay, so we're going to say sine. Okay, so we are going to say sine 15 degrees. So again, they could give it to you as sine 15 degrees, or they would give it to you as pi 2 over. So you know, to convert, so you get your 15 degrees, right? That's if you want to convert. So sometimes they would give you as what? They may give it to you as sine, assign that. So when they give it to you as that, meaning the same methods that we are going to use, but you just have to replace where we will be putting degrees, just convert those degrees into radians, and you can calculate. It's the same principles. So what we are going to do then is sine 15. Now I'm sure by now you see that we can use a lot of methods, right? By now you know that we can use the addition and subtraction identities, but we already did that yesterday. So let's make use of the what? Let's make use of the half angle formula. So before you start solving, you want to ask yourself that in which quadrant is angle 15 degrees in? Okay, so what quadrant? Okay, so what quadrant is this going to be in? So I'm sure everyone should be telling me that it's going to be in quadrant 1. So why am I interested to know where my quadrant 1 is? Because when I'm using the half angle formula, the sign is very very important, okay? Because remember, we said something about where we said sine for the half angle formula. It's that. So you're asking yourself, is this going to be a negative or a positive what? Or a positive answer? So what you are then looking at is you want to figure out this angle that I've been given. What's the value of sine in that particular angle? So when you look at 15, when you draw this, and this is where many people make mistakes. So when you look at angle 15 will be somewhere here, right? So what quadrant is this? That's the first quadrant, right? And remember I said all students take coffee. So in the first quadrant, all the cos, the sine, the what, they are going to be positive. Then in the second quadrant, what's going to be positive is sine and cosec. Now I'm wondering, why have I added cosec? I've added cosec because cosec is what? Cosec is 1 over sine. So meaning if sine is positive, meaning cosec is going to be positive as well. I hope that makes sense, right? Then the other thing that I would like to take note of then, you say let's now go to the third quadrant, right? So the third quadrant, so this is the first, this is the second, this is the third, and this is the fourth quadrant. So then for tan, in the third quadrant is going to be positive, but it's not only tan as well, it's going to be tan and cot. Tan and cot. We know cot is what? Cot is 1 over tan. And then the same thing for the fourth, it's going to be cos theta and what? And sec. We know that sec is what? Is 1 over cos. So I hope everyone has been able to appreciate that. So now, having done that, so can someone tell me what sign our formula is going to have for this half angle? Yes, so it's going to be a what? It's going to be a positive sign. So please, that point is very very important, especially you see for those other questions that we'll be doing where you have to build on this and then to find other questions as well. So sorry, pardon me. So what then we are going to do, we know that this is quadrant 1. So sine 15, so that's plus. So then you may be wondering, okay, so what would be my angle? So it never hurts. Let's just look at a quick way of how you can find this. So you say, so what you do is you say, this is pi. Sorry, let's say this is 15 degrees, and 15 degrees is x over 2. Okay, so how do you find x? So you just cross multiply. You know, some things, these things look, but when there is exam pressure, sometimes it can be so easy to write something else. Huh? So that's that. So we figured that out. So what you do, you may want to write the full formula. Then you've seen on the second one, that's where I've just used the positive, right? So cos is what? Cos is 30 degrees there over 2. Now, can someone tell us what cos 30 degrees is? Hello? Okay, so what we do is, so there is over 2. So there's over 2. Then we know that cos 30 is what? It's going to be square root 3 over 2. So, you know, people know these special angles. You know, in your exam, in your test, they will never give them to you. Okay? So, having done that, then you want. Okay, thank you. So, that's that. So, now we want to simplify what's on top, right? So, how we are going to simplify? We are going to find, so let's put the positive to maintain it. So now on top, for the numerator, we find the common denominator, and the common denominator is going to be what? It's going to be 2. Maybe let's do this. Maybe for those that may not be able to see this, what we are having as our numerator is this. So we just want to have a common denominator here. So we have 2, that's going to be 2, then that's going to be that. Okay? So that's just basically what we have done here. Okay, I'm hoping we are all on the same page. Then remember, there is a 2 here. Okay, so what then we are going to do is, I've just, okay, let's continue using the same red. So so what we do then, we know, okay, so let us maintain the plus there. So what we are going to do is 2 minus that, then over, now we know that this over 2, it's going to be what? When we change it, it's going to be, remember with division, this is 2 over 1, right? The one that is on the bottom here. So when you do the reciprocal to this, it's going to be 1 over 2. So you multiply here. uh yeah, so there you're going to what? You're going to multiply that, isn't it? So 1 over 2, which is going to give you, so that's going to be 2 minus 3 over 4. Now you see that what we have for our denominator, that's a perfect square, right? So we can actually separate them to be able to find that. Okay, so what you then do at this point is you can say, okay, remember, again, here you need to be really good with your SADs, because remember what, like when we discussed SADs, we said if you've got something like this, it's the same as that. Okay, so we're just going to break it here again, because we know that we can simply find the square root of 4. So sometimes you can find others will just leave it on this point. If you leave it here, you can lose marks, because they expect you to be able to see that you can find the square root of 4. So that's basically about it. So are there any questions? Hello? So is everyone clear? Hello, is everyone clear? Okay. So okay. So now since we've done things in degrees, let's do one in radians because usually it's radians that usually unsettles people. Okay. So now you are looking at that particular angle. So what you are trying to do first of all is you want to put yourself in a position where you say, okay, so what can I do to, first of all, you want to know what quadrant, yes? Okay, okay, I see. So usually, uh, if they want to test you on half angle formula, they will specify. But if they are silent, pretty much you just look at convenience. Okay? So you basically look at something that is what? Something that is convenient for you. Okay? Yeah. So that's something that's very, very important to take note. But yeah, that's a very, very valid question. That's a very, very valid question. That's a very, very valid question. So yeah, so that's the key thing. So what you want to do is read the question, and usually the question what will be able to guide you. But that's a very, very good, profound question. So we now look at that. So remember, looking at this can confuse you. Like, okay, oh my goodness, what's this? So always try just somewhere convert it to degrees, okay? Just convert it to degrees, and when you convert it to degrees, then you'll be able to see, oh, okay, because you want to know what is the what is the quadrant that you are working with, right? So this angle in degrees it's 157.5. Okay, so that's what that angle is in degrees. So once you've done this, you know, okay, of course, the moment you just see that point 0.5, you know that you have to use the half angle formula because you know because that's because which angle can you get which you can add anyway. Maybe you can add two angles to give you that, but again, without using a calculator, it's almost impossible to find a point 0.5 what a point 0.5 angle. So what you're going to do, I'm sure we discussed the what the coterminal angles, right? Okay, we discussed that. I'm sure of we discussed. Okay, so what this tells us is this: coterminal angles, coterminal angles, coterminal angles. Can someone do cos 315? Cos 315 gives you square root of 2 over 2. And you see that cos 45 gives you the same. That's because they are what? Coterminal angles. Anyway, we discussed that last time, so there is no need for me to go into details. So that's the lovely angle that we are looking at there. So then, how then do we proceed with this? Interesting. So what we are going to do for this one, we know that this is a point 0.5, so meaning we definitely have to use the what? The half angle formula. Now, we know I gave us about three formulae that we could use for tan, right? So for me, in the interest of time, I think I'll use this than the one that has got two. two square roots. That seems anyway. But yeah, you could use those for practice, but we'll use this and the answer will be the same if you want to compare it on the calculator. So that's it, right? So then you are now asking yourself what angle, because this angle, you know that this angle is for what? The angle that we've been given, we are taking it as x over 2, then our formula is coming out like that, right? So then we want to find now what our x is, or what our angle is that we're going to plug in at this point. So what we're going to do, just multiply this by 2. That's going to give you what? That's going to give you 315. And that's why you have to know the coterminal angles. So 315. So that's angle 315. Now, you'll be wondering, what's going to be 315 for this? Again, that's why you need your what? Coterminal angles. So again, remember, but we are working in radians. And remember, like I said, even during sketching, when they give you a question in radians, solve it in radians. So to find half of this, you say, you're going to say that is that. That was this. If this is half, so meaning you simply multiply through to get x. Okay, so that's going to be 4. So that's going to be 7 pi over 4. Then it's going to be x. Okay, so that's your x. Okay, so I hope that's clear. So meaning that, but again, we know that in degrees, that x is what? That's 315 degrees. Remember, degrees are easier than radians. Yeah, like who wants to use radians? But you just have to ensure that you are showing you're working in radians, so that you don't lose marks. So now we can now write this and say tan 7 pi over 8 is what? Is 1 cos. So you see now our x is now going to be 7 pi over 4. Okay, let me just wrap this and write it somewhere here so that people can follow. Okay, so that's our x, right? So once we do that, then on the right track. So that's sine x, that's what? 7 pi over 4. Now, can someone tell me what cos 315 is? Perhaps you are checking, cos 315, how do I? So you use the coterminal angles. Okay, so since we are looking for cos 315, because this one that we found, remember it's what? It's 315 degrees, right? So how do you find the coterminal angle? Anyway, but we discussed this. So the coterminal angle for 315 it's going to be the same as what? As 45 degrees. So you subtract from 360, right? So you've got a coterminal angle. So if you want, you can check it on the calculator right now to say cos 315 and cos 45. You get the same answer. So meaning for cos 315 it's the same as just writing out your that thing that you know for cos 45. So you just simply write that answer that you know for what? That you know for cos 45. So once you do that, you're on the right track. So you do that, then you going to be that over that, then over. Now, something that's important to take note of is this. Let's first think about what quadrant we are in, because that's something that's very, very important to take note of. So we are in what quadrant? We are in 350. So we are looking at what angle? 157. So 157 is the second quadrant, right? So all students take coffee. So meaning in this one, it's only what? It's only sine, which is going to be what? Which is going to be uh positive, right? So meaning that the answer that we are going to get has to be a negative. That makes sense, right? Yeah, so that's what should happen. So this means that even if you were to type on your calculator tan 157.5, you see it's giving a what? A negative answer. So that's the thing, right? Because in the second quarter, so if you do your calculation and then you are finding a positive answer, then you know that there's something that you are doing wrong. So let's now go for cos. So for cos, we calculated what? That was cos 315. 315 is in what quadrant? 315 is in what quadrant? The fourth quadrant, isn't it? So if it's in the fourth quadrant, that's why our answer for cos, you see, it's remained a positive, right? So now let's look at sine. Sine there on the denominator, it's sine what? That's sine 3, 315. What sign should that value have? Should it be negative or positive? Huh? So it's going to be, hello, it's going to be negative. So it's going to be negative. So meaning once you've done here, this is the hardest part really, because most people, they'll put what? They'll put for sign, they'll put a positive 2, and then they get everything wrong. Huh? So please take note of all students take coffee. That's very, very important. People get these questions wrong even when they're supposed to do justice to themselves and get it right. So again, what do? We want to, for the numerator, we want to put the denominator there. So there it's going to be 2 and there it's going to be like that, right? Then for this denominator, it's going to change, right? What was down goes up, what was up goes down. So that's what we are looking at, right? Is it? Okay. So what we do, those cancel. The negative gives us, so the negative gives us negative 2, positive 2, and then we have that. Okay. So we have that, right? Then you know that we never want to leave a base being a root. Again, that's where many people lose marks as well. They will leave the answer here forgetting that, from rules of what's this, of SADs, you never leave an answer with the base being a what? Being a SAD. Okay? That makes sense, right? So you never leave an answer with the denominator being a what? With the denominator being a sad. So please let's take note of these things. These are small mistakes that people make, and they pay huge prices. So you rationalize the denominator. So rationalizing, we do that. Then we are going to do what? Multiply through. So it's going to be multiplying through, it's going to be negative 2 there. Then someone was asking this question yesterday. So to that one that was asking yesterday, now this is where we have 2 because they are the same, okay? It's like this principle of sides. So someone that was asking, so I just thought I should remind them there. Okay, so then we've got that. So here it's going to be 2. Then the denominator is going to be 2 as well. But we are not yet done because you can still factor this thing. So what you do, you say, let me factor 2 out. So it's going to be negative that plus 1 over 2, isn't it? So you cancel that, you're getting negative 2 and plus 1. So when you try and when you are practicing, when you try to put this negative square root 2, okay, plus 1, the answer that you are getting, you see that the answer that you are getting, okay, so I think it's better to write it, it's more accurate to write it like this, I think. Yeah, so you see that the answer that you are going to get is negative 0.414, which is the same when you do tan 157.5. So again, what is important, you've seen that your tan is what? Your tan, the answer is negative. And that makes sense because this angle 157, it's in the second quadrant. So if we found our tan being positive, then we should raise our eyebrows. Then it means there's something wrong that we've done. That makes sense, right? So that's how you do these questions, right? So yeah, so I think since we've looked at sine, tan, I think we can leave these ones and let's look at how they would ask questions for the double angles. So for the double angles, they will say, and I'm sure these ones are in your tutorial sheet. So they will say, s- since someone said that they were asking how they ask this question, so I think maybe writing this may help. So that's pi over 2. Huh? Okay. Find. So now this is an interesting question. Why is an interesting question? Because for you to be able to solve, so you have to find sine 2x, cos 2x. Now, one thing that you have to remember for these particular things is this thing that they've given you, this range, that's where the money really is. Because you know what that range tells you? That range tells you whether sine is going to be positive, whether cos is going to be positive, whether tan is going to be positive. So I would argue that this range is very, 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 very important. Okay, and I know most people don't like radians, so this is the same as 0 degrees to 90. Okay, to 90 degrees, right? Yeah, that should be it. Is it? Okay, yeah. So now you see, so that's what we are looking at. So when you look at that, that's in the pretty much in the first quadrant, right? So since you know that it's in the first quadrant, what this means is you're asking yourself to say, okay, so what happens in the first quadrant? You know that all of them, all these, all remember, all students take coffee, all students take coffee, right? So meaning you know that in the first quadrant, all of them are going to be positive. In the second quadrant, it's sine and cosec. In the third, it's going to be tan and cotangent. Then in the fourth quadrant, it's going to be cos and sec and secant. So there we have it, right? So what you then do now is, okay, before you can do that, you may want to write your formulae. So for these questions, it's just basically about the technique and the formula. Because you can know the technique, you forget the formula, it doesn't do much, or vice versa. So practice is the key. Okay, that's that. What else? Okay, so the reason why I've written this is so that you could see that for us to answer these questions, we have to find the what? We have to find the values for the other things, right? For cos, for tan, and those things. So what we want to do then, what we are going to do then is, we know that our angle is in the first quadrant. So what we do is we draw this xy plane, and since our angle is in the first quadrant, so we are going to put a triangle in the first quadrant. Remember, we've put the first quadrant because that's where our range is. So we know that sine, the angle is here, is first quadrant. So sine is what? Sine is opposite. Opposite is 5. Then, because remember, our sine is 5 over 13. So opposite is what? Opposite is 5. Then hypotenuse is 13. Okay, that makes sense, right? So once we've done that, then that's what the money really is. Then now we now want to find out the what our x is. Because remember, if we are to find cos, cos is what? Cos is going to be adjacent over hypotenuse. So we want to find the x as well. So for this one, what we are going to do, so for this one, what we are going to do is we are going to calculate x. So we are going to solve what x is. So we are going to use the Pythagoras theorem, right? And what we are going to do is we know that hypotenuse, is 13 squared. Then you've got 5 squared. Then you've got x squared. So what you're having is 13 squared minus 5 squared. So that's what? That's 169, right? Then that's 25. Then that's x squared. That's 144 and x squared. Okay, so let's then say, so square root of that, x is 12. So meaning our x there is what? Our x is 12. So meaning with this, we can calculate now our cos. So meaning cos x is going to be what? Again, we take x as this angle that, okay, I think this will confuse. Let's think of it as cos theta, right? So that angle there, right? So you can say cos theta, right? So let's not confuse it. But anyway, it's going to be adjacent. Adjacent is what? Is 12. Then over hypotenuse, right? Remember your SOHCAHTOA. Okay, so over what? Over hypotenuse. So you've gotten your cot. So now your cos. Let's find our tan. Tan is going to be opposite over adjacent. Of course, you could easily find this just simply by dividing your sine over cos. Okay, so that's about it. So now the other thing where many people make mistakes is the signs. Okay, so what quadrant is this? This is the first quadrant. Can someone tell me, is sine going to be positive? Is cos going to be positive in this quadrant? Yes, so it's going to be positive, right? So we leave it, so it's positive, right? Then what about tan? Is it going to be positive in the first quadrant? Yes, it's going to be what? Positive. So these are very important because sometimes you see people forget these things and they get it wrong when they're supposed to get full marks, and it's really sad. So with that, we just now begin to plug what we found into these equations. Okay, so we now start with sine 2x. So this one is what is sine is 2 sine x cos x. So we're having 2. Then this is what? This is 5 over 13. And this is 12 over 13. Now, is it? Is it? Okay, yeah. Okay. So can someone help me with the calculations? So on top it's going to be what? On top it's going to be 60. Yeah, it's going to be 60. It's going to be 120, right? Over. It's going to be 120 over what? That's 169, right? Wait, have we made a mistake somewhere? Okay, but that's what it should be, right? Let's first look at our course. Yeah, that's how it should be, right? We made a mistake. No, that's how it should be. Okay, so once we've done that, we're on the right track. So let's now go to the second part. So yeah, then that's you can't break that one down into any other way. So it's enough to leave it there. So that's 144 over 169. Then that's 120. Sorry, that's 25 over 169. So that's going to be what? Um, that's going to be 119 over 169, right? Again, you can't break that any simpler than that. Then we now have this one tan 2x. Okay, so there. So it was 5 over 12. Okay, so again, this may be a lot of math, but it's just arithmetics. So in the interest of time, let's just put the answer there. But yeah, you could do your calculations in case you find something different. Then I've just made a mistake in my calculation. But once you are here, it's just algebra. Anyway. Yeah, there's nothing trigonometric there. It's just algebra. So um, so let's now look at something interesting here. Mm, how can we look at this? Now take note of, right? If we wanted, we could use just this sine 2x and the cos 2x to find tan 2x by simply saying what was our value for sine 2x. So it's what? Sine was what? over, so we come here and say, then the reciprocal of the denominator, that gives us what? Okay, let's write it here so that it may adds up. So we cancel that, we cancel that, that's 120 over 19, which is pretty much what we found, right? Yeah, so you could do that as well, especially because in the exam you're always trying to save time, right? Hello, are there any questions? Hello, hello. Okay, so so then um what we would do, I'll just write this question, and to be important for those who want to try it, they could try it, and then yeah, just for practice sake. But the next time we meet, we'll be looking at trigonometric equations, which is the last part of this topic, right? So probably next week we should be able to start um calculus. So let's yeah. So find those, given that tan x is equal to, let me write it properly, given that tan x is equals to 3 over 4, then your range is pi. So from this you should be able to tell what quadrant you are looking at and how that is going to affect your values. So that's pretty much about identities. And I'm sure you saw on Moodle I posted a video that has got 14 examples on verifying trigonometric identities. A YouTube video, you can look it up on Google Classroom, and I feel that is going to help just to look at different ways in which you can look at these things. So I think with what we've now gathered, I think we can now proceed to look at trigonometric function. Sorry, to look at trigonometric equations. So